Hello, we're continuing here with energy sources in Energy 101. We've looked at coal, we've looked at oil, we've looked at natural gas, and now we're going to look at natural gas liquids. Natural gas liquids is not something you hear about very often, but they're becoming increasingly important because of the increased production that we're getting from natural gas liquids. What are natural gas liquids? Well, natural gas liquids is a byproduct of natural gas production, and they come at the well. In other words, they come out of the ground just like natural gas. As a matter of fact, they come with natural gas. That's the reason they're called natural gas liquids, and they are receiving increased attention due to the increased natural gas production. And so when you increase natural gas production, you increase the natural gas liquids that come with them. So what are natural gas liquids? Compared to, if we look at the molecular structure, compared first to natural gas itself, natural gas is a methane molecule of 1 carbon and 4 hydrogens. And at atmospheric temperature and pressure, it is a gas. And as a matter of fact, to get it to a liquid, you have to actually cool it to minus 260 degrees Fahrenheit. No matter how high you take the pressure, natural gas will not liquefy. That is not true with natural gas liquids. Natural gas liquids are those gases and heavier hydrocarbons than CH4 that come out with natural gas. And if you pressurize the natural gas with natural gas liquids together, the natural gas liquids will form liquid droplets and you can separate it. So the liquids that come out with the natural gas is ethane, C2H6, propane, C3H8, butane, C4H10, isobutane, which turns out to have the same chemical formula, C4H10, but it's an isomer of butane. We won't deal with the chemistry of what an isomer is for now. And pentanes, which are C5H12. And pentanes actually come out at atmospheric temperature and pressure as liquids. All the rest of them they actually come out as gas and don't liquefy until you pressurize them. But you're familiar with propane or butane because we use it in our grills, our home grills, to barbecue and things. And we also use it in tanks at a lot of homes to heat homes. But they have to be pressurized. And if you reduce the pressure to atmospheric pressure, which we do when we use them, just like in a gas grill, there's a pressure regulator that drops the pressure from 50 or 100 pounds per square inch down to atmospheric pressure. The liquid that's in the tank turns back into a gas, as they were when they came out of the ground. So that's why we call them natural gas liquids. They're gases, except for pentane, that come out of the ground with natural gas production, and they are hydrocarbons, as we see here. So what are the general characteristics? Well, as I've already commented, they come out of the ground with natural gas and the gaseous state. And we then pressurize the mixture, and we separate the natural gas liquids. And so they all liquefy when you pressurize them, except pentane, which is liquid at atmospheric, and it comes out of the ground and at atmospheric pressure is already a liquid. But counter to these natural gas liquids, natural gas itself, even though we pressurize it when it comes out of the ground to separate the liquids, the natural gas itself will not liquefy. As a matter of fact, it'll never liquefy at atmospheric temperature, no matter what pressure you take it to. That's just the nature of methane. So we'll talk later about liquefied natural gas, LNG, which is totally different from NGLs. So we got confusing nomenclature here, but natural gas liquids are these things that we just mentioned, the ethanes, the butanes, and the propanes, and the pentanes. And but if we take natural gas and refrigerate it to extremely cold temperatures, minus 260 degrees Fahrenheit, then natural gas itself will liquefy, and we call that liquefied natural gas. So the liquid is on the front end for liquefied natural gas rather than tail end of natural gas liquid. So don't get confused over that, that nomenclature that is used commonly in the industry. So what is the production of natural gas liquids and what's the trend? Well, you can see from this graph that over here on the right, out here at 2011, the production has gone up significantly. And it was fairly level from 1981 at 1.5 million barrels a day until it grows gradually up to about 1.8 million barrels a day in 2007, and since then has increased to about 2002 barrels of oil, barrels of liquids a day that comes out here in the U.S. with the natural gas and is used and marketed and processed. So production has gone up, as I mentioned. That's because of the horizontal well natural gas fracking that has surged natural gas production, because the production of natural gas and the production of natural gas liquids go up together. So we have had a surge, and that's why people are talking about them more now. But that's the trend. It's not dramatic, but it's up from 1.7, 1.8 to 2.2. So that's about a 20% increase, which is a significant increase. So how much is that compared to crude oil? Compared to crude oil in barrels, you can, here's they're showing the two together, stacked together. So the dark blue is the production of oil in million barrels a day, and we see how it declined from 1981 down to 2008. Where it hit about 5 million barrels a day, and now has increased up to about 6 million barrels a day. So out here, so it's 6 million barrels per day here, and here it was down about 5.7 or 5.5. So oil production has increased, and natural gas liquids have increased also by this amount right here, compared to this back in 2008. So it does add to the liquefied petroleum production in the U.S. And we'll get to the confusion over that and how comparing these and adding natural gas liquids to oil is sometimes appropriate and sometimes totally inappropriate. And we'll see why it might be inappropriate, because they don't totally trade off. You can't utilize one for the other and displace oil, for instance, with natural gas liquids on a one-to-one basis. Well, why is that? What are some of the uses for natural gas liquids? The natural gas liquids is dominated by the ethane. We mentioned before the chemical content and the different components of natural gas liquids, and here they are listed again: ethane, propane, butane, isobutane, and pentane. But you can see the largest percentage of natural gas liquids comes out as ethane. Well, how do we use ethane, and how valuable is it to us? Well, it's made to make plastics and antifreeze. And the primary manufacturing sector that uses this is the manufacture of plastics. So it's valuable to us, and we're using it in this case for the molecule. We're not burning that chemical molecule ethane. We're using the molecule for the characteristics of the molecule that allow us to make plastics, which of course is growing and has grown for many, many years. Propane, as already mentioned, is another component, and it's used for home heating and gas grills, and liquefied petroleum gas. Liquefied petroleum gas here, the LPG that you hear a lot of times, is generally a mixture of propane and butane together. But it's dominated by building heating. Most of the propane is used for heating of buildings, and also some for transportation. we can run cars off of propane. Just have tanks in the trunk, just like the tanks are different shape and different size that we use in home grills. But we put them in cars, and the car can run with a fairly inexpensive conversion off of propane. Butane is about 7% of the natural gas liquid production. It's used for synthetic rubber, lighter fluids, and LPG again, because LPG is a mixture of these two. So those are used for, butane is used for manufacturing LPG, and again, some for transportation. In the cold climates, butane is a problem because when it gets cold, the pressure of the tank of the butane liquid tank goes down, and in very cold weather it becomes atmospheric pressure or less, and you can't get it out. So butane is mostly useful in the warmer climates, not the colder climates. The propane can be used in the colder climates as well as the warmer climates. Isobutane, what's its utilization? It's used for chemicals, making chemicals, and used in the gasoline refining process. And but the primary sector is manufacturing, and also some transportation there, but mostly manufacturing. Pentanes, by the way, is different from the rest of these liquids in that it is liquid at atmospheric temperature and pressure, but it makes up about 14%. And it's used in gasolines, and polystyrene blowing, which is foam, and it's used primarily for transportation because it's used in the production and refinery of gasoline. So this gives us some clue about what some of the trade-offs and displacement might occur of like natural gas liquids with crude oil. So if we produce an extra barrel of natural gas liquids, will it decrease and substitute for a barrel of crude oil? Well, probably not, because about at least, number one, the ethane is not used in crude oil type of applications. And that's the biggest chunk. Propane is used very little. It supplies maybe 0.1% or less of the transportation fuel. So right there you've got the dominant components of natural gas liquids. So you really can't displace. If you produce an extra barrel of natural gas liquids, it doesn't displace and save a barrel of oil. They can't be done on a one-to-one basis. So in many cases they shouldn't be lumped together, and yet because natural gas liquids are up, and the common term used for petroleum liquids that includes natural gas liquids and crude oil, and by the way ethanol, which we'll talk about later, is a common term. And a lot of times the production of petroleum liquids will be reported, but sometimes it can be a little bit like adding pounds of gold to pounds of silver. You can say, well, I've got 20 pounds of gold and silver, but that doesn't really tell you anything about the value of that 20 pounds, because you have to know the components and you have to know what each one's worth. So the value of the natural gas liquids relative to oil, which is the one that we have an import problem with, as we've seen a little bit already, is not necessarily solved with natural gas liquids. But if you approximate it, somewhere maybe 1 barrel of natural gas liquids will displace about 1/3 of the barrel of oil, because they're used in the gasoline refinery process and et cetera. Matter of fact, I've read some articles lately, the chemical industries and the fossil fuel industries a little worried about how they're going to use these natural gas liquids with all this increased production, because the demand in the marketplace may not be there for continuing increased natural gas liquids. So all fossil fuels are not made the same. Obviously, we can't, for instance, throw a chunk of coal into our car and run our car with it. So coal and oil is not equivalent, and natural gas liquids and oil is not equivalent either. But if we add, petroleum U.S. liquid petroleum, and we look at the percent imported, then we come up with a different number: crude oil plus natural gas liquids. We won't look at this slide too much, because I'll talk more about this issue more later. But you hear different numbers about what percent of our energy and oil do we import versus produce here. And if you add natural gas liquids to oil, which this one does, whereas we got about 60% before, it's about 55% or a little less in the case of liquid petroleum. What's the other use? What's the other transportation fuels? I mentioned natural gas liquids as transportation fuel. The gasoline, of course, is the big one at 72%, diesel at 23%, but the other one is ethanol, which is 5%, and we're going to look at this in the next lecture. And you can see compressed natural gas, biodiesel, and propane, when you round them off, it's less than 0.5% of our total transportation fuel. So natural gas liquids are not real important or significantly important in our transportation base. Thank you.